So the first type of mass movement I want to talk about is the slowest, and that's called creep. So with creep, we have this very slow downhill movement of this material on top that we call the regolith. So basically what happens is every year, especially up north, the material undergoes freezing and thawing. So in the wintertime, the ground freezes, and when it freezes, it expands, and when it thaws, it contracts. So what happens is as it freezes and thaws, as it expands and contracts, the material moves, right? So you can get this very slow downhill movement. And when I say slow, you can't watch it happen. So it's incredibly slow. And usually we only get different type of features that you can see afterwards that tell us creep is happening. So here you can see, this is my personal favorite, you have these bent trees right here. So basically what happened is, this is the original position the tree up here is marking the original position of the ground. Let me switch to a different color right here. And what happened is the ground is slowly moving this way, so it's pulling the roots, but the tree is still maintaining where it originally started growing. So you get these really cool bends in the trees. Or the same thing here in cemeteries. It's real easy to see. So for example, this tombstone here, the top of the tombstone is showing you where the original position was, and the ground is slowly moving this way underneath it. So you can't watch creep happen as it's occurring, but you can see the after effects of it for sure. The next one's just a little bit faster, and this is soil deflection. So soil deflection is where we get this very slow downhill movement of material. So this is the downhill movement of material. But what makes this a little bit different than what we saw with creep is that this happens in areas of tundra. And with the tundra, we have to have ground that is permanently frozen. So basically what you would have is, down here you have a layer that's completely frozen, and then you've got sediment sitting on top of the soil. It's this soil that moves. The frozen part stays frozen, so it's basically sliding on top of that frozen part. So as a result, you can see how this is flowing downhill. You can kind of see these waves in here. So definitely easy to see soil deflection. So it's a little bit faster than creep. Picking up speed slightly, our next one is rock glaciers. And here you can see that we have a glacier, and that glacier definitely isn't pretty white with snow. It's full of a lot of material. Glaciers are very abrasive as they move over the sediment or over the ground itself. They act like sandpaper, and just kind of rubbing and picking up all of this material as they move. So, and then of course the more material it picks up, the more rough it's going to become on the rocks that are sitting below it. So what's pulling this glacier downhill is gravity, so we have this very slow movement of ice and rock that's moving. And of course over time what will eventually happen is that glacier will melt, and all of that material will drop out of the glacier. Then we have slumping, which is a little bit faster. It takes a while for slumping to occur, but when it happens faster than the ones we've seen previously. So slumping occurs when the side of a hill basically becomes unstable, and it falls apart in these big blocks. So here you can see we had a hill like this, and this material inside became unstable, and it started to fall down, but it falls in these big coherent blocks, as you can see. This part down here is what we call the toe of the slump, and right here where it broke off is what we call the head scarp. So here in this picture, you can see there's the head scarp. You can see how it fell apart in these big distinct blocks, and you've got this big mass down here, right, that the toe of the slump. Slumps are very common in riverbanks or sides of the road. Riverbanks, obviously, as rivers work through, they cut pretty steep cliffs. Here you can see this is a very steep head scarp, and we've got all this material sitting here at the base. Here we have a road cut, and you can see the head scarp just starting to form. Eventually, all of this material will fall downwards. And of course, that can become dangerous because it can easily bury the road, And hopefully there's nobody on the road, right, when something like that happens. Moving a little bit faster, we have our mud flows, debris flows, and lahars. What makes this a little bit different is this is all water-rich movement. So instead of just gravity being the main agent here, we have gravity plus water. So this moves a little bit faster. We can see that there's slow moving, but not as slow as creep, but it's going to also move pretty fast. Because water is the agent there, this is going to flow down river channels, and it's going to spread out, and it can carry, as you can see here in this picture, some very, very large material as this water-rich material moves downhill very quickly. So let's look at mud flows. So mud flows are aptly named because it's water and mud. And so it's very fine sediment. Remember, mud is just clay and silt mixed together. We tend to see this happen in areas that receive a lot of rainfall. So here this is in South America. You can see the side of this hill gave way, and it's all this mud flow that just kind of came down and buried this whole area. So this is going to be very fast movement and pretty sudden movement, and it's just going to bury everything that's right at the base. Then we can have debris flow, which is basically a mud flow with rocks in it. So we have lots of fine material and lots of much larger material, as you can see here. It's pretty easy to pick out where the debris flow happened all along this area, because there's no trees. So as that material moved downhill pretty quickly, it just wiped everything out in its path. Then, of course, we have our lahars, which we talked about in the igneous rock chapter. Remember, as a lahar is where we have all of this glacial ice or snow that's sitting on top of our volcano, and as that magma rises, that material is going to start to melt, and that melt can come down pretty quickly. So that water is also carrying lots of volcanic ash and sediment with it, and it's going to come down the side of that volcano pretty quickly. And here again, this is the same picture that we saw in our igneous chapter in Colombia. Right before the volcano erupted, the snow cap came down and melted, and you can see here it's got this very fast-moving water full of sediment, right? Because you can see it's not crystal clear. And this was a farm field, and the sad thing about this is, as this water rushed down, it buried this whole town and ended up killing about 20,000 people. So again, lahars are very dangerous. Obviously, living at the base of a volcano is dangerous. But then you also have to deal with the mud flows that occur as well. Moving into even bigger size sediment, we have our rock slides and debris slides. This is sudden downhill movement where you don't necessarily need water. This is mostly gravity. So a rock slide is a slide consisting of rock. So this picture here is a rock slide, very large pieces. A debris slide is where we have much smaller pieces coming down. You can have rocks as well, but you're going to have lots of soil and mud coming down. The interesting thing about debris slides is because it's very fine, very small sediment, as that material moves downhill, it can pick up speed because it could ride essentially on a cushion of air as it comes down. And it can go well over 300 kilometers an hour. So this is very fast-moving material. Then, of course, we can have an avalanche, which an avalanche is a cloud of debris and air. So it's not just these big heavy pieces that are moving. You get lots of fine material creating this cloud. Of course, you can get a snow avalanche, right? There's here, right? So it's just the downhill movement of snow. Basically, what happens is the side of the hill becomes too steep, and gravity is going to start taking effect. And it's going to pull all of that snow downwards. And avalanches, right, snow avalanches, snow doesn't seem like it can be that dangerous, but it can really wipe out an area. Here we have an after picture. So this is after a snow avalanche has occurred. And of course in the springtime, so all the snow is melted. But you can see how it wiped out the trees in this whole area. So avalanches just aren't this movement of this nice pretty snow. It really wipes everything out in its way. An avalanche can come in two different types. We can have a wet avalanche or a dry avalanche. For our snow, a wet avalanche is where it's going to be move down like a slurry, so it's going to be a little bit wetter. It's going to move fairly slowly, but what you see in movies are the dry avalanches. This is what this picture is a dry avalanche. This is moving very fast, well over 250 kilometers an hour. And as that snow moves downhill, because it's moving, again, kind of on a layer of air and it's very dry, it creates all these big billowy clouds as it moves downwards. So avalanches can come in two types. We can get a snow avalanche or a debris avalanche. Snow avalanche is what we just talked about. A debris avalanche is essentially the same thing, but with rocks and dust instead of snow. And they can also move fairly quick, just like that dry snow avalanche, about 250 kilometers an hour or so. And then, of course, finally we can get our rock falls and debris falls, this is material that's in free fall. So this is what happens at the edge of a cliff. So a rock fall is where we've got rocks literally just free falling. You can see here, right, just kind of literally fell down, straight down. And then a debris fall is essentially the same thing, but with much smaller pieces. And it's easy to pick out where a rock fall or a debris fall has occurred, because you get these very large talus piles that happen at the base of the cliffs.